Okay, so today we wanted to talk about 7.6 vectors. Okay, so we were introduce the definition of the vectors, the visualization of the vectors, multiplication, addition, subtraction, and represent vectors in the rectangular coordinate system, and perform operations in the terms I and j, which are the unit vectors. Okay, so and we also solve applied problem involving vectors. Okay, so what is a vector? So quantities that involve both a magnitude and direction are called vectors. So what does this mean? So you have a magnitude. This color is not good. Yeah. So you have a line segment. You have a magnitude, and it will be called a vector if you also give it a direction. Yeah, so a vector is a directed line segment. And a scalar is you have only the segment without the direction, means without the signs, then it is called a scalar. So what will be a vector? So it will be called what? A direct line segment. Yeah. So and P is called what? The initial, and Q is called what? The terminal. And the magnitude of the directed line segment is called the length, and we denote PQ. Okay, so it is right like PQ means from the initial to the end, and the magnitude is defined as PQ. Okay, so a vector is directed. So what will be the vector? Okay, so it will be from the initial to the end to the terminal. Okay, to the terminal. Okay, so this is how we write. Okay, so in print means you can use bold and to represent the vectors, but when you write it, how could you make it bold? It's not clear. So typically we write VW with the arrow on the top. That means vectors. Okay, and the magnitude is more like what? Apps value. Yeah, so it's double apps value maybe. Okay. So, and the next thing that are very important, if two vectors are equal to each other, then we should have the same magnitude and what? The same direction. Yeah, so the first one, same magnitude, same direction. This is same magnitude but different direction, opposite direction, and it's not the same magnitude. Yeah, but one thing you need to be careful. Okay, so look at the first one. They are the same. So for the two vectors are the same, but we do not care the initial and the terminal. No, we do not care. Maybe where the vector begins and ends. You with me? So if you can start with here, 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 or you can even start from here to here. Okay, as long as it has the same magnitude, same direction, they are the same. So it does not matter where it starts and where it ends. So this is a very important property. Okay, vectors. Okay, so if you wanted to solve two vectors that are the same, then what do you need to solve? We need to solve what? Magnitude plus what? Direction. Okay, so where the direction come from? The slope. And where the magnitude come from? The length. Okay, so if you have two vectors, UV, so it's starting from what? 2 points. This is P1, Q1, P2, Q2. Okay, P1, Q1, P2, Q2. Okay, so what will be the length here? Square root of what? X2 minus x1 squared. JC is what? The distance between 2 points, yeah? So we all know that JC is okay. Then you calculate the distance of the other 2 points. The other 2 points you can calculate, yeah? And how could you find the direction? Direction comes from what? The slope, yeah? So what is the slope again? This is the distance, yeah? What is the slope? Is what? Y2 minus y1 over x2 minus x1, yeah? So then you can do the y2 minus y1 over x2 minus x1, yeah? So you calculate both. So it's 6 minus 2, 5. 6 minus 2 and negative 2 minus negative 5. Be careful with the signs, yeah? So negative 2 minus minus is what? Plus is what? 3 or 4. Or, 5 minus 2 here. Okay? Okay. Perfect. And then you can see, you can make a conclusion. They have the same magnitude. They have the same slope. Okay, so same slope. What does this mean? These two vectors are the same, are equal. Okay, so the next one is called what? Scalar multiplication. What is a scalar? It's only a number, yeah? So a number times a vector. So what happens? So if the number is what? Positive, then what do you have? Same direction, yeah? Yeah. And if the number here is what? Negative, then what do you have? Opposite. Okay, and the values of the number will change what? Change the what? The magnitude, yeah? So if you like, 5 times the vector v, it instead of the magnitude, it will be 5 times the magnitude, yeah? So that's pretty, easy. Okay, so what will we have? So the vector kv has a magnitude absolute k times this. So the k will change the magnitude, and the direction is controlled by the what? The sign of k. So if it's positive, then it's the same direction. If it's opposite, if it's negative, it will be what? The opposite direction. Okay, so this is this one. Okay, so the next one is too interesting one. So the sum of two vectors, okay? So the sum of two vectors. So vectors, we do not care where is the start, yeah? So u, if we wanted u plus v, okay, so what will we do? We have the initial and we have what? Terminal, yeah? Okay, so what will be u plus v? What will we think about this? Yeah, so if we have a v right here, yeah, initial and this, yeah. So what will we do? We wanted to move the initial of v to the terminal here. So it's not a good picture. So we wanted, wanted to make it almost the same, yeah? Forget about me. I will try the last time, okay? So you know that I'm not good at this. Sorry about this. Okay, so this is, okay, so same direction, same what? Magnitude, yeah? Okay, so what will you do? You put the initial to the terminal and then keep the thing, yeah? Okay, so what will be u plus v? U plus v, it will be the new initial at the new terminal here, yeah? Okay, so u plus v, it will be this. You with me? So what happens here? You just connect these two vectors, yeah? Two vectors, so it's very easy to understand, yeah? So it's obvious, okay? Okay, so what happens with v minus u? Okay, so I will not use the book's one. So v minus u. So if you have a v, and what will you do with the u? we used to put what initial and terminal, make it here for the u. Okay, so for v minus u, what will we do? We will put two initial together. Together. V minus u. So, okay, so if we use v minus u, so the final direction should follow what? V. Okay, so v minus u should what? Follow v here. Okay. Okay, so what will it be? This is v minus u. Yeah, think about this. U is here, yeah, plus v minus u, u plus v minus u. What does this thing equal to? That's v, yeah. So this is what? Initial end, and you put the initial to the terminal here, yeah, and then you think about this, okay? So this one is what? This. Okay, so if v minus u is on this thing, okay, so think about this. It's more like what? A parallelogram. So if here is u, here is v, yeah? Okay, so what is this one? This is u plus v. Okay, and this diagonal is what? U minus v. Okay, so this is how you draw the picture. If you add, you connect the initial with terminal together. If you subtract, you connect what? Two initial points together, and then connect the other two sides. Okay. So the next thing we wanted to introduce are two unit vectors. What means unit vector? So whose direction is, the I is what? On the positive axis. And this one is on the positive y-axis. What is the unit mean? Means the magnitude of I and the magnitude of j is always equal to what? 1. So it's like a unit circle. The radius of the circle is 1. So the unit vector is the magnitude of the vector is 1. Okay. So, because we are writing, we are not print, we better use the arrow sign. Okay. Okay. So then we wanted to use another way to represent vectors is represent vectors in the rectangular coordinates. So v equal to ai plus what? bj. Okay, so what happens here? So if you have a point, yeah, ab here, and if you connect the point with the origin here and give the direction, so you start from the origin, go to the point, this is the initial, this is the end, and then give the direction. What happens? You give a vector, yeah? So what will be this vector? It will be what? ai plus what? bj. Your a is your what? X coordinate, and your b is your y coordinate. You can also write as what? ai bj, because I is the unit vector on the x-axis, j is the unit vector on the y-axis, yeah? So, and similarly, the magnitude is the distance here, yeah? So here is a, here is b. Pythagorean theorem is what? Square root of a squared plus what? b squared. Okay, and ai plus bj is also called what? Linear combination, because I is a vector, j is also a vector. This will be useful in your later course called linear algebra. Okay. Okay, so sketch the vector 3i minus what? 3j, and find its magnitude, yeah? So what is a here? 3. B is what? Negative 3. So what will we do? We find the point. 3, negative 3. So first thing you find the point 1, 2, 3, 1, 2, 3, negative 3. So this is the point, yeah. So what will be the vector? You connect this vector with the origin, give it a direction. This will be the direction. And this is the vector, yeah. What will be the magnitude? The magnitude can be what? Square root of a squared plus b squared, no? Okay, so you do not need what, 0, 0 anymore. So because you know that is a plus b squared, yeah? So square root of 3 squared plus 3 squared, square root of 18, that's what? 3 square root of 2. Okay? Okay, so the other way to represent vectors is what? Your initial at the end, okay? So then is what? P1, P2 is x2 minus x1, y2 minus y1j. Okay, so this is, I think on the top example, they have already used this example here. So if you are given a point here and you use this one, and then you can also use x2 minus x1, y2 minus y1. Okay, so what I will remember, I will call this one initial. This is your terminal. So what will be the vector? It will be what? Terminal subtract with the initial. Okay, so it's the terminal subtract the initial. Okay, so is what point was P1, P2, yeah, so write in the form of I and J. So it's terminal subtract with the initial. X subtract your x coordinate, y subtract your y coordinate here, yeah? So 2 minus negative 1, 3 minus 3, 7 minus 3, so it's 3i plus what? 4j. Okay, so what is this? So we draw a picture here. This is the vector. So if we draw from 0 to 3, 4, what is this vector called? It's called what? Position vector. And these two vectors are exactly the same. Yeah, so this because you have the same magnitude and what? Same direction, yeah? So, and this P1, P2 give you a vector, okay? And this vector starting from the origin is called what? The position vector, okay? So the position vector. Okay, so the next thing we wanted to talk about is what? Adding and subtracting vectors. So how could you add and subtract? You just what? Add this is also called what? Horizontal ones. This is your vertical component. So your vertical component is just like what? Your y component. Your horizontal component is what? Your x component. What will you do? You add two things together. You add the x component and the y component, or subtract the x and subtract the y. Okay, so this is pretty straightforward. So 7 plus 4 is 11. 3 minus 5 is what? Negative 2. When you subtract, you need to be a little bit careful. 7 minus 4. 3 minus what? Keep the sign, negative 5. So 3 minus negative 5 is plus 5, which will give you what? 8. Okay, good. Okay, so a scalar multiplication. Okay, so a scalar multiplication, you need to be a little bit careful. K times v. Do not forget, you have to distribute the k. It's k times the horizontal component, k also times what? Vertical component. You with me? So k has to multiply both component, both ones. Okay. So if we here 8v, what will you do? 8 times 7i plus what? 8 times 10j. So it's 56i plus what? 80j. So negative 5v, what will it be? So okay, so I need to remember, put the arrows. Okay, so it's negative 5 times 7i and plus negative 5 times 10j. Yeah, so it's negative 35i minus what, 50j. Good. Okay, so the same here. Okay, so what means zero vector? So you have a zero component in both horizontal and vertical. Okay, both horizontal and vertical. So these are the vector addition things. Okay, so what do we have? We also have what? Commutative property, associative property, and additive identity, and additive inverse. Okay, so it's same as what, when you add numbers, or you, okay, so you have associative properties, all this commutative. Okay, so u plus v equal to v plus u any vector plus 0 is it will be itself. U plus what, negative u, its opposite vector will give you the 0 vectors. Okay, so you also have what, product, scalar multiplication properties. Okay, so this is pretty straightforward too. It's the same as what, numbers. Yeah, so CDU is just like U as X. You can distribute, you can multiply 1, you can multiply 0, and do these things. Okay, so these things are very important in the course called linear algebra in the future too. Okay, so a unit vector is defined to be a vector whose magnitude is what, 1. So we have already talked about this. Okay, we have already talked about this. So finding the unit vector. So how could you find the unit vector? This is a very important one. Okay, so what will you do? This is any vector. So if you divide its magnitude, what happened? If you find the magnitude of v, yeah, so this is a number, so you keep the number here, yeah, so then you just find the magnitude of the top. It's always equal to 1. Okay, so this tells you the magnitude equal to 1 here, yeah. So because why the magnitude of v is itself, the magnitude of the magnitude, it will be the magnitude, because this is only a number, it's not a vector anymore. Okay, so this is why you can put it out. Okay, so find a unit vector here. So v equal to this. In order to find the unit vector, we need to find the formula. Yeah. So first find the magnitude. This is find the magnitude, square root of a squared plus b squared. So square root of 4 squared plus 1, negative 3 squared. Be careful, negative 3 squared. The negative sign goes away. Yeah. So this will be 16 plus 9. Square root 25, which will be 5. So what will you do is v over the magnitude of v, so it's 4i minus 3j over 5. Okay, so this means everything divide 5. Yeah, so every component is 4 over 5 minus what, 3 over 5. Okay, and then you can continue to verify the magnitude. So square root of what, 4 over 5 square plus what, negative 3 over 5 square. You will see the magnitude is actually 1. Okay, so we wanted writing a vector in terms of its magnitude and direction. This is a very important one. Okay, so the v will be equal to what? The magnitude of v times cosine, magnitude of v times sine. Okay, so v equal to what? AI plus what? BJ. Okay, so what is A? A is actually your what? This is actually your what? X coordinate. Think about this. And B is your what? Y coordinate. Yeah, Y coordinate. With me? And so what will be the X coordinate? Is always, think about this related with what? Polar. r cosine and y equal to r sine. It's almost similar, yeah? So what is r? It's the magnitude, yeah? So then what will be a? A is the magnitude times what? Cosine. The b is what? The magnitude times what? Sine. It's very similar. Very similar. So this is to write this, okay? So your magnitude is almost like r in polar coordinates, okay? So writing a vector whose magnitude and direction are given, okay? So if you have a jet stream is blowing at 60 miles per hour in the direction northeast 45 degrees, it expresses velocity as a vector in terms of I and j. Okay, so we know that this is 60 and the direction here is what? 45. Yeah, so we know that magnitude of v is what? 60 and the angle theta is 45 degrees. Yeah, so what will be the a here? Is v cosine. What will be b? It's v what? Sine. So because what are you doing? You are doing x and y coordinate here. X and y coordinate here. Okay? So this is what you have here. With me? So this is how you do this one. Okay, so the last one. So if you have two forces, F1 and F2, magnitude of 630 and 60 pounds respective, and act on an object. The direction of F1 is northeast 10 degrees. Direction of F2 is northeast 60 degrees. Find the magnitude and to the nearest tenth, and then the direction of the angle to the nearest tenth of the resultant force. This one is a tricky one. Okay, so what I wanted to do here is I wanted to do it with you carefully. Okay. Okay, so what I will do is I will copy a black page and work with you. Okay, so what I will do is, okay, so we use the picture here. Okay, so we have the F, this is F1, this is what? F2. Okay, so and what do we want? We wanted the resultant one, yeah? So resultant one means what? F1 vector plus F2 vector. Yeah, so this is the resultant one. So F1, F2. So we wanted vector with plus vector. So what do we only know? We only know the F1 what? Magnitude of the F1 is what? 30. The magnitude of F2 is what? 60. And what else do we know? We know that is what? The angle, yeah? So this is northeast 10 degrees. So northeast 10 degrees. What does this tell you? This part is 10, yeah? And then what do we want the angle here? We want this angle, yeah? So we know that the theta 1 here is equal to what? Is equal to what? Is 90 degrees minus 10 degrees, which will be what? 80. And similarly, theta 2 is what? 90 degrees minus what? 60 degrees will be what? 30 degrees. Okay, so this is the information that we get it from the question, yeah? And what we want? We wanted F1 plus F2. we want addition of two vectors. So first thing, we need to find what are these two vectors. We only know the magnitude and we only know the angle. Yeah, so because we only know the magnitude and we know the angle. Could we write the vectors? Yes. So f1, which will be equal to what? The magnitude of f1 times cosine 80 degrees. That will be the horizontal. And plus what? f1 times what? Sine of 80 degrees times what? J. That is the vertical asymptote. What will it be for the f2? It will be the magnitude of f2 times what? Cosine 30 degrees I, and the magnitude of f2 times what? Sine of 30 degrees J. Are you with me? Then what will you do? Use your what? Algebra to find each vector. Then after this, what will you do? You add these two vectors what? Together. That will be what? Your f1 and f2. That will be what? The resultant vector. Are you with me? And then what happens? After you find the vector, you find what? The magnitude. Using what? Square root of a squared plus what? B squared. That will be ai plus something, you get it from there. Are you with me? So this is the sketch of how you work out. The first thing, because when a lot of students will say, 30 pounds and 60 pounds, that's the horizontal component and the vertical component. No, so that is the magnitude of the f1 and f2. You have to find the vector first. Okay, you have to find the vector first. Okay, so this is so you find the vector of the f1, you find the vector of the f2. Then what should you do? You add the x component, add the y component to give you the vector f. Yeah. And then what will you do? You find the magnitude using the formula, and then you find the angle using all these things. Okay, so that will be the example of this application. Okay.